Hello everyone. So this is the next chapter or next course related with the protein structure validation. In the previous one, I get a very good feedback, so I just start the second one. So here I am just describing about what is the energy involved and what are the bonds and what are the interaction involved in the protein structure. So first of all, it's important that have to have information about what is the bond. Bond means suppose if one atom and second atoms, if both are interact with each other, if one atom moves in some place, so other atoms also move with that place. Same like a cycle. Suppose wheel of the cycle, if one wheel of cycle move forward, so other is also have moved to forward, so both are interact with each other, such type of person. Particularly in this case, bond, what is, suppose if one atom, suppose if it has a 10 proton, so 10 proton and 10 electrons just revolving, and 10 electron are some, because they want to just make up with the 10 electron and the same things. So if a covalent bond, so electron will be share, if the electrostatic bond, so electron will be transfer, such type of things. So ultimately they have a interact with each other, and ultimately if one moves, so other is also moving in that same direction. So that's a bond. Now is a bond angle. Suppose if two atoms, so definitely it has an interaction with a bond. If it's third atom, so third atoms have some angle between them, so that's a bond angle. And that angle, particular in the concept of the protein structure, it based upon the side chain, because the rest all things are common, only the side chains of every amino acid are changes. So suppose the glycine and alanine, suppose these are the some contain small side chain, and tyrosine, tryptophan, phenylalanine, so they have a large bulky group. So on the basis of this side change, the interaction between these residue will be changed, because I already told this all the game of the electron cloud. If electron cloud the tryptophan is too much, so it definitely has some impact on the bond angle. So ultimately the bond angle will be less or high on the basis of the side chain. And in energy terms, two are proper improper dihedral angle and proper dihedral angle. Dihedral angle is nothing, is suppose if uh, one how do I say, if some atoms are in that, is they are just in the one plane, some are in the other plane, some are in the other plane, so then what are the angle between them? So that's angle is a dihedral angle. And dihedral angle, particularly in this case, we can suppose these blue blonde the below surface look like a one angle, one plane, other plane, and that's the angle is an improper dihedral angle and proper dihedral angle. Another thing is that the bond nature, suppose if two atoms are interact with each other and two more atoms, so because these are interact with each other, and so these two atoms are moving in that fashion, so such type of bond is also possible in this case of protein level. And if suppose the how do I say, if suppose electron cloud of two atoms, same similar atom, they just say overlap, or they did not overlap, they just parallel or anti-parallel. So until and unless at that condition the atoms or atoms in particular one state have a higher binding energy and have a lower binding energy. So on the basis of higher binding energy and lower binding energy, the protein electron count will be shared in the different orientation. If in the parallel, so they are in the higher binding energy, and if they are lower anti-parallel, they are lower binding energy. So that's a proper dihedral link. Actually there are also and different formulas also, but for the beginner I would prefer that up to now you have to have this information. Now I just describe more information about what are the bond interaction. So electrostatic energy or non-bonding terms, so like electrostatic energy or electrostatic bond or ionic bond. So here in this case, the positive charge and negative charge. So positive charge and negative charge are only based on the electron. You don't have to just concern that what is the positive charge means proton or negative charge electron, because electrons are maybe high or maybe low, because suppose as I told you it's 10 proton, and if 11 electron is moving, so it has one negative charge. And if 9 electron is moving, so it have one positive charge. Just because of electron are less or electron are more. If electron are more, in contrast with the positive charge, so it have a negative charge atoms. And if electron are less, in contrast of the proton, so it have positive charge. So if electron, suppose 10 proton and 9 electron is moving, so ultimately this atom or system has a one positive charge. And if 10 proton and 11 electron is moving, so the system has a one negative charge. So ultimately, if such type of things happen, so they interact with each other. One electron from one atom just relocate on the second atom, and on that region, in this condition, they are just interact with each other. So such type of interaction is called electrostatic bond. And electrostatic bond is a very strong bond. Now that is a van der Waals bond, and van der Waals bond is very important bond or higher in number in the case of the protein structure. And what exactly it is? It is, suppose if two atoms, as I already told, suppose you just go through the same example. If two atoms are interact with each other by electrostatic or such type, suppose if two atoms are far away, but if they have side chains of these atoms or some other bulky group or some other group, so if they some other groups push these atoms to move towards that atom, the same thing from that atom is also surrounded by some other nearby atoms, and if that atom is also pushed to move toward this atom, so ultimately they just come closer to each other, and in that fashion van der Waals interaction will be involved. So what will happen? What in the van der Waals interaction? Suppose if this atom has a positive charge and the electron is moving surrounded here. Okay. If the another atom is just come closer, so the electron cloud of the second atoms also in the range of the positive charge of that first atom. So this electron cloud is also interact with positive charge of first atom. So what will happen? Positive charge of proton of the one atom interact with electron cloud of the first atom, its own atom, and also electron cloud of the second atoms. The same in the second case, positive charge of the second atoms interact with electron cloud of the second atom and also electron cloud of the first atom. So if such type of things happen, so van der Waals interaction will happen. And so this is a higher in number, but is a very weak interaction and is very, very important in the case of the protein structure preparation. Third is the hydrogen bond and also disulfide and some other. But I was thinking that up to now you have to have information what is the electrostatic bond, what is the covalent bond or van der Waals bond. So covalent bond means the electron cloud are CS the same orientation from both. That's very common, particularly here in the hydrogen bond important. So as you know, the covalent bond, suppose one electron from one electron or up to now one electron or two electron. Suppose one electron shared from one atom and second electron also share the same atom. So say electron cloud of the first atom, some electron of the first atom, and some electron of the second atom are in the middle. And such type of interaction is called covalent bond, not hydrogen bond. That's a covalent bond. Such type of things happen if normal case covalent bond. But if the electron cloud are the shift into one position, one orientation, so ultimately what will happen? The electron cloud move into one orientation and away from the another orientation. So ultimately they have to induce some positive charge on one atom and some negative charge on the second atom. I think you better to understand what exactly I have to say. Electron cloud normal in case in the middle in the covalent bond, but in the hydrogen bond, electron cloud are shifted in one atom towards one atom and shifted away from the one atom. So ultimately electron cloud is a negative charge. So if shifted towards an atom, so it produces some positive partial negative charge and some partial positive charge. So such type of interaction will happen in the case of hydrogen bond, and that happened because electron affinity are the different from the hydrogen and oxygen molecule, because hydrogen is the extreme left in the periodic table and oxygen in the extreme right, not extreme right but up to right in the periodic table, and these both have a changes in the electron affinity. Some have higher electron affinity, some have lower electron affinity. So ultimately the electron got shifted towards it, and such type of interaction is highly possible in the protein structure. And one more thing, here in this case protein structure, we say this is a not a hydrogen, this is a salt bridge interaction. No, this is the hydrogen bond, but ionic bond is called a salt bridge interaction. Particularly in this case, if you just go through literature, ionic interaction is called salt bridge interaction. And then the secondary structure, same thing as I already told in the first one. What is the beta seed? Beta seed supposes the 1, 2, 3, 4 atoms, and if they interact with the far away atoms from the 1 with the 15, 6, 2 with the 16, 3 with 17, 4 with 18, if they interact in this fashion, so they like a seed like structure, one seed, one seed. So if these both seeds are in the same orientation, so it's called parallel seed. If are opposite orientation, it's called anti-parallel seed. And such type of interaction is called beta seed. It's very common, and that depends upon the hydrogen bond. If hydrogen bond are taking away from too much atom, that's I told you is a parallel seed and anti-parallel seed. And alpha helix, if the first atom interact with the fourth atom, second with fifth atom, third with sixth atom, fourth with seventh atom, fourth with eighth atom. So suppose if one with fourth, second with fifth, third with sixth, fourth with eighth, seventh. Okay, such type. So they just create a helix like structure. So such type of helix is formed on the secondary structure on the basis of hydrogen bond. If they interact every fourth amino acid, so such type of things will happen. And so is such type of things is possible in the case of secondary structure on the basis of helical structure. So on the orientation, if every fourth, so is a helix 310. If a helix 3.6, so is a helix alpha. And on the basis of hydrogen bond distances, secondary structure. So helix 310 is also helix alpha, helix alpha or alpha helix. And in some cases, some other helix are 0.4 nanometer. So they are non-stable, or you just can say in the unstable. So up to now, I think it's important that you have to have this information, keep in your mind. In the next class or in the next tutorial, I will just go through a more detail about what are the other things related with the protein structure. But I think if you have any problem or any query, just please text me. And so much thank you very much.